Alhamdulillah Rabbil Alameen. Again, Allah gave us opportunity to do another class. Yes, so we must thank Allah for it. Quickly, we don't have time. The Assis Salah will be 30 minutes time. Okay, Assis Salah here is 3 o'clock. We are going to deal with, continue on with our periodic table, Group O. Okay, Group O. The Group O, they are helium, neon, argon, krypton, xenon, and radon. Okay? So basically the first point I'm going to raise is the group 0 or group O, they are called, who knows them? They are called noble gases. Why they are called noble gases? I'm going to explain. You know, we said that the cells of an atom consist of K cell, L cell, M cell, and you go. Okay? Now, K cell, the maximum electron it can take is 2. L, maximum 8, the rest all maximum 8. Okay? So that's why we said this is a noble gas configuration, meaning it has the maximum number of electrons in the outermost cell. So, all the noble gases have 8 electrons in their outermost cell. Okay? That being the maximum. Therefore, noble gases, they are very, very unreactive. Okay? Very unreactive. So there's something like saying that the reactivity increases as you go down or go up. Okay? Very unreactive. Very unreactive. Because they have the maximum number of electrons. The maximum number of electrons in their outermost cell. In their outermost cell. So, we can see the element just before this. Let's say take chlorine. We can say chlorine have 7 electrons in outermost cell. Okay? Chlorine, Cl. So therefore, it can accept 1 electron, okay, to make it 8. So when it becomes 8, it cannot react to any. It already has now got a noble gas configuration, okay? It now has a noble gas configuration. Okay? But the noble gases, already, they have 8. Already they have 8 in their outermost cell. Let's say neon. Okay? Neon, Ne. So neon cannot accept electron from an ionic bond. You know, ionic bonding, the non-metals, they accept electrons. Okay? The metal, they give electrons. But you can only give electron if you have at least 3 electrons in outermost cell. Because if you look at it, sodium, it has 1 electron in outermost cell, 281 in it. Okay? All the one they have 281. You go to the group 2, group 1, they all have 2, 8, they all have 2 in the outermost cell, 2, 8, 8, 2 in it. You go to group 3, they'll be 2, 8, 3. Okay? You go to group 4, they have 4. This is where donation of atoms stop. Sorry, donation of electron stop. When you go to 4, like carbon, 2, 4, you see, to give all the 4 electrons out will be very, very difficult. You understand? So they form covalent bond. If you have group 5, they have 5 electrons in the outermost cell. If you want to donate all these electrons, it means you have involved a lot of energy. Okay? So naturally, they receive electrons instead of giving it out. See? Now, if you come to 6, it's become extremely difficult. 7, extremely difficult. 8, you reach the maximum number of electrons. That's why these ones, metals can give electrons, but non-metal can receive electrons. They cannot give out all the 7 in the outermost cell. They can do that. Okay? That's why they are called non-metal, because they receive electrons. You understand? So, when they react with group 1, group 2, group 3, they form metallic compound. When they react among themselves, you call, yes, covalent bond, they form covalent bond. No, metallic bond will be that one here. That one and them. Okay, metal and non-metal will form covalent. Sorry, ionic bonds. Yes, covalent. Non-metal among themselves they form covalent bonding. Yes. So therefore, because they have 8 electrons in their outermost shell, they are called innate. What is the meaning of innate in English? Inert.
Inactive.
Inactive, yes.
Or dormant. Or like
Dormant.
reactive.
Dormant, yes. Innate, in fact, means dormant. Dormant in English. Dormant means sleepy. Okay? Or impotent. Okay? They are impotent. Okay? So if they are man, we say they cannot produce children. Okay? They are impotent. So that's them. They cannot do any reaction with any other element. So they are called inert gases. Okay? Now let's look at their characteristics. Where is it? Positive. Now, you should all know that they are they are called mono, okay, they are mono element, yes, mono molecular element, gases, sorry, mono molecular gases. It's finished. Yeah. They are monomolecular gases, yes? Monomolecular gases. Oh, it's because it's wet, isn't it? Oh, there you are. There you are. Yes. I told you they are called monomolecular or monoatomic gases. Okay? The reason is the other gases in group 7, you know, we read them as fluorine as F2 in it, chlorine as C2 in it. So they are diatomic, yes, because it means they have a covalent bond. Because these people have less than 8 electrons in their outermost cell, so they can react and form a covalent bond in it. Chlorine in it. 7, 6, 8. Same chlorine, yes? This is Cl2. It means 2 chlorine atoms form a covalent bond. But this guy, can they form a covalent bond? I mean the group 8. No, why? Because already they have full configuration. So if they form a covalent bond, they're going to 16. Understand? Or more than 10 here. Because they make 10. So that's impossible. That's not possible. That's why they are called monoatomic gases. So, meaning that they are all gases at room temperature. Okay? They are all physical properties. They are all colorless gases. Yes? Number 2, they are colorless gases. Okay? They are colorless gases. Yes? 3. Okay? As you go down the group, okay, would you say the activity increase or decrease?
Decrease.
What do you say, Ali?
They stay the same.
Okay, what do you say?
Same.
Same. I saw that question. I saw a guy ask people, if a plane full cross Uganda into Zambia and it crashes, where are the survivors going to be buried? Where are the survivors going to be buried?
In the plane.
Huh? Where, are they going to be buried in Uganda or in Tanzania? Where are the survivors going to be buried?
Where they crashed.
Where are the survivors going to be buried?
Is there many survivors from the crash?
Pardon?
Will there be survivors? Or this comes back?
What do you think? Where are you going to bury them?
I think back in the home country.
Huh?
Wait, are they going to be buried there?
Okay, where do you think they're going to be buried? Survivors going to be buried. Survivors.
The survivors?
Oh,
Wait, they're not dead. They're not dead. You can't bury survivors. The survivors because they're not dead.
Oh, yeah!
So if somebody says the activity increase, okay, down or up the series, okay, that means you don't even know what these gases are. There's no reaction. That's why they are called inert gases. You know what I mean? So there's nothing like reactive increase or decrease. What you can talk about is the boiling point, okay, or the melting point, okay? And you expect each of these to increase down because the atoms are becoming bigger and bigger and bigger, okay? Even though they are inert gases, but still there's positive and negative, meaning there's a proton, okay? There's a proton here which is positive, and there's electrons around it which are negative in it. So there are still intermolecular forces in it. Now the Russian scientist was able to do something with these things, yes? The Russian scientist was able to bombard the helium atom, and kick out an electron outside, okay? And try to make it react with another metal or whatever. See? Those are chemistries you never see them in the textbooks. These are hidden chemistry because they are for military. They are for military purposes. Okay, yes, you don't see them in the textbooks. Okay. Now they are all colorless gases. Yes, so they don't react with any metal or non-metal. Yes, they don't react with any other element, okay? Any other element. This is because they have full number of electrons in the atomous cell, in their atomous cell, okay? So, now, if boiling point increase as you come down, melting point increase as you come down, what do you think will be molecular mass numbers? Come on. What do you think about the mass numbers? Increase or decrease as you come down?
They'll increase as you come down.
Why do they increase?
Because there's more electrons.
More electrons and what?
More protons.
We said as you go down, look at this. Lithium, sodium, potassium. 281, 2881. As you go down, what happened to the next one? One more cell in it. That's right. So the atom is becoming bigger and bigger. Bigger and bigger. So if it becomes bigger and bigger, that means the atomic mass number is increasing. See? 3, 11, 19 in it. Okay? So the atomic number is becoming bigger and bigger. So as you come down, the atomic become bigger. Now, if an exam question can come like this, if xenon boiling point is 25 degrees centigrade, okay, let's say they are gases, so you expect them to have very low boiling point. Put it in mind, gases have very low boiling point, okay? Now, what do you think will be the boiling point of neon? Higher or lower?
Higher.
Yeah, higher.
That's what we have just been saying.
Neon. Oh, say the same.
The boiling point increases as you go down.
Increases.
Yes, the melting point increases as you go down, innit? Yes, that's what I'm saying. That's what we say. Okay? Number 4, we said that the boiling and melting point, and we explain what is a boiling point. This is temperature at which, okay, it turns from liquid to gas. Although these people are already gases, okay? But they still have boiling points. Melting points increase as you move down the group. Okay? This is because the atoms get bigger as more cells are added, yes? More cells. You know the cell are added. Okay? Also, it means also the electrostatic forces, yes? Electrostatic forces or pull from the nucleus increases. Increases, yes? We saw the electrostatic pull. The electrostatic pull increases, okay? Non-metals. But for metals, it decreases. That's why we're discussing it. Okay? We said potassium is very reactive because the pull of the nucleus on the last electron is getting weaker and weaker as you go down this group in it. So that means boiling point, melting point, or decrease in it. Okay? That's the opposite of the non-gases. Sorry, the non-metals, yes, and the gases. That's what we said yesterday. So you must know that, yes? If you're ready with that, Mitchell. So, exam question can say, as I tell you here, okay, the boiling point of xenon is 25 degrees Celsius. Okay? What would you predict to be the boiling point of neon? Okay? So if the boiling point of xenon is 25 degrees Celsius, okay? What will likely to be the boiling point of neon? Neon is how many other elements down? 1, 2, this is the third one up. Yeah? Okay? So this basically you can know that the boiling point of xenon is minus 25. That of neon will have to be lower than in 25, yes? Maybe 5 degrees centigrade, yes? You can be talking about 5 degrees, yes? Okay? So, another question. Let me show you a question. I'll show you a question here. I don't know whether you will use your brain, because this is, that's all. It says, the question says that radon has boiling point of minus 62 degrees centigrade, okay? And krypton has boiling point of minus 150 degrees centigrade. You can see these are, 100 degrees is far below the glass, isn't it? Glass happens at which degrees? At what time may water become glass? What's the boiling point of water? 100 degrees. What's the melting point of water? What's the melting point of water?
Melting point of water?
Zero.
What is the freezing point of water? At what temperature water become turned from liquid to gas? We are going to do state of matter. That will be next topic, yeah? The state of matter. The temperature at which water become solid, ice, is 0 degrees, isn't it? Yeah, 0 degrees. And it boils and melts, it boils at 100 degrees. It turns to gas, isn't it? We're going to do this state of the matter. So even if you apply a temperature of even minus 15 degrees, which is far less than the melting point of water, this thing can boil. Okay? So it says, predict, the exam question said, predict the boiling point of xenon. What do you think? Predict the boiling point of xenon.
I think, I'd subtract them from each other. I think I'd subtract 153 minus 62.
Okay, you subtract the two, 153 minus 62 in it. That will be what?
That would be 90.
2 minus this is 1. 9 carry 1, 91 in it. 91 minus 91 degrees centigrade. Yes, that's a good idea. What's another idea?
In between the two.
In between the two,
Yeah.
So in between two, we will what? If you say what is the number between 6 and 8, what would you say? 7, yes? Half. That's right. That's what I want to hear. It's going to be between half, the average of the two in it. Yes? Minus 153. You remember our minus will be? Minus in it. Don't say minus is, yes. somebody was responding to my classes online. Ahmad Manjang, my brother in Riyadh. He said, you explain it like this. If you have a basket, yes, of small balls, okay, this one is called minus ball, minus ball, minus, that's minus dice. These are minus dice. They're called minus dice. How many minus dice are there?
9.
9. Ooh. So, if you take out 3 of them, you take minus 3 minus dice in it. You take out another 3, another 3 minus dice in it. So how many minus dice?
3.
Minus 6. Yes, 6 dice. This way you should explain it. Okay? Now this is the end of it. This is the end of this. There's no reaction. There's nothing else. It's physical and chemical. There's no like chemical reaction. There's also physical observation about how they appear and how they appear. Okay? Now the last one, you see this question, how they can twist this. Okay? The last one is flammability. What do you mean by flammability? Flammable. It means catch fire in it. Fire, again, yes, burn. Okay? These things, they don't burn. Why? Because they are very, very inert. They are inert gases, so they don't burn, yes? Yeah, they don't burn, so they are noble gases, yes? So the last one is they are not flammable, yes? Not flammable. They are not flammable. So you may ask, what are they used for? They are used to form, helium bulb, helium or neon bulb, yes?
I'm sure you can get all the last one, isn't it?
Yeah, neon bulb, yes? And they used to fill balloons in it. Balloons, yes. Neon, yes? You see, when people, you have these big balloons going up in the sky, yeah, they put helium in it, yes? Yes. So basically, these are the well-known use for these noble gases, yes? That's all about noble gases, not much, okay? What we have to know is the boiling point and boiling point increase are still going down because the atom is getting bigger, more cells have been added, the electrostatic forces are increasing, okay? Yeah, so, and there's no reactivity. If this is 60 degrees, that will be less and less and less because it increased down here. Okay, that's all we know about noble gases, okay? You can go and play now.